Hello, chemistry students. Welcome to lesson 2 for the week of April 6th. Today we're going to take a look at what happens when gas laws are mixed. Okay. So when solving gas law problems, choosing which gas law to use can be the most difficult. Pretty much what we've done so far is last week we just did Boyle's law one day, and then we just did Charles' law. Lesson 1 this week we just did ideal gas law. But realistically, you don't know which one to use. You're not told which one to use. So your best tool in identifying which gas law to use, which equation to use, is the units that are given to you in the problem. And we did an exercise like this last week, but we're going to do it again because it's that important. Your units are your best friends. I've said it a million times and you're sick of it. I know. So when I say units, I'm talking about like millimeters of mercury, mmHg, Celsius, liters, kPa, kilopascals, milliliters, atmospheres, Kelvin. Okay, that tells us what variables we're using. So I filled out this first one for you. It's pressure, and we give it the symbol P. So we identify the pressure units because they are always given in atmospheres, kPa, or mmHg. So pause. If you can fill out this whole table before I tell you, do it. I've had a lot of students tell me that they're copying, they don't have a printer at home, but they're super smart, and I guess you guys are just better at computers than me. They've created a Google Doc where they can copy and paste from Canvas, and then they can edit the Google Doc so that they can take notes without having to print it or write it out. So hopefully you're able to do one of those things. But for our pressure, we have a total of 3 more, okay, or a total of 3. Okay, number 1, number 4, and number 7. Those are pressure values. Looking at volume values. Volume, remember, is going to always be given in the units, liters or milliliters. So hopefully you found the 3 volume values right there. And then for temperature, we're given temperature in either degrees Celsius or Kelvin. So those are our 2 remaining ones. Okay. Now using those skills, we're going to also do just a quick summary of our 4 gas laws that we've learned during this Corona chemistry. So for Dalton's gas law, that was way back in the first week, which feels like a month ago. It's so weird. But for Dalton's law, the only variable is pressure. So it was the total pressure and the partial pressure, but you would only have pressure units. As far as relationship and graph, that doesn't really apply. Those 2 columns really only apply for Boyle's law and Charles' law. Okay? So Dalton's the pressure guy. He only cares about pressure. For Boyle's law, the memory trick that I like to use is that one. You guys look at my fun little animation. It took me way too long, guys. This is silly. But I like to say that Boyle's hides his units in his name. So he hides the P for pressure in his name and the V for volume in his name. So Boyle's law will have the variables for pressure and volume. So you'll have numbers with atmospheres and liters, something like that. Now, relationships, very important. You definitely need to know that Boyle's law has an inverse relationship between pressure and volume. So that means if one is going up, the other is going down. And we graph inverse relationships like that. Okay? So if you're handwriting this out, make sure you're pausing so you can do this. For Charles' law, the memory trick that we like to use is that Charles watches direct TV. So we've got, if I can make this work. Oh, there it is. Okay. Charles watches direct TV. It's the direct relationship between temperature and volume, which gives you the next answer as well, that the relationship is direct. Wow, there we go. So that means they go in the same direction. Volume and temperature increase together or they decrease together. And we graph it like that. It ends up being a straight line, direct relationship. Okay. This is stuff that you're going to have memorized for our little end of the week quiz, which as a reminder is your major grade. Okay, we're taking an average of your end of the week quizzes as your major grade. Okay. The ideal gas law that we learned about in lesson 1 this week has all 4 variables. So that means P for pressure, volume, moles, which we use N, and then temperature. And then again, relationship and graph doesn't quite apply. So using this table that summarizes our gas laws, we're going to look at these examples. So it says 1 through 7, okay? We have 7 gas laws that we're identifying. This is how you do it, guys. You box in your given, you circle your unknown, so you know what equation to use. So I'm going to switch over to my document camera so that y'all can see me do some of these problems with. Okay, so here we are with the document camera. All right, you'll see I've got my table that I filled out, and then identifying gas law examples. So we're not going to have you calculate these today, which is super nice of us, because that's a whole bunch more work, and we know you guys are overwhelmed with stuff right now. But I just want you to be able to say which gas law it is. So you'll see that I've already boxed and circled mine. I boxed in all of the numbers and units I saw, so those ones, and I circled the question. They're asking me what volume. All right? So the variables used, well, volume is definitely one of them. So I'm going to write just V for volume. Okay. The other one, liters, is another volume unit. Temperature of Kelvin. So I've got a temperature and a temperature of Kelvin. Okay. So the only variables I see are 2 volumes and 2 temperatures. So usually we'd have you turn to the back of your periodic table and find the equation. Okay. The equation that has 2 V's and 2 T's. And it's that one right there. Okay. That would be the equation we would use to solve this. You don't need to do the math, but you do need to know whose gas law this is. So TV, Charles watches DirecTV. So that means this is a Charles law. Okay, and then that's all you have to put. And it's actually, apostrophe goes there. It's annoying. All right, let's look at number 2 on the next page. Pull this over. Okay. I've already boxed and circled number 2, if I can find it. So what is the final volume? I've got a volume of a liter, which is volume. Pressure, ATM. And it's moved to a standard pressure, which I know is 1 ATM, because it's on the back of my periodic table. So what are the variables used? I have 2 volumes and 2 pressures. Whose gas law is that then? Well, you just ask his name. It's hidden in his name. Boyle's, P and V, hidden right in the name. So this is going to be a Boyle's law equation. If you've been watching the homework video tutorials, Miss O'Brien says you boil your peas and vegetables for the P and V. That's another way to remember it. Okay. If I had asked you to solve this, which we're not, but if I had asked you to solve it, you would look at the back of your periodic table and choose, let me get that out of the way, choose the equation with 2 P's and 2 V's. Okay. Number 3, the total pressure of 4 gases is kPa, is a pressure unit. Partial pressures are 85 kPa, so another pressure, kPa, pressure, kPa, pressure. They're asking you for partial pressure. Okay, so my only variable is pressure. Okay, and remember from our notes, Dalton's law has only pressure in it, so that makes this a Dalton problem. Okay, I'm going to ask you to pause this and do the last 3 on your own. Seriously, try it on your own, please. Thank you so much for pausing it and trying it on your own, because that's exactly what your chemistry's your homework's gonna look like today. So I wanted you to practice. I appreciate you doing that, hopefully. All right, calculate the pressure of, so here's a number I'm gonna box. They're asking me to calculate the pressure, so I'm going to circle that. So pressure, they told me moles, which is N, of helium gas at this Kelvin temperature, and volume, there we go. So this is giving me pressure, moles, temperature, and volume. So one of each is going to be this equation, which is the ideal gas law. I know R isn't in the equation. It's because R is not a variable. It's a constant. Okay, so this is the ideal gas law. Now, really, and I'm going to highlight this one. Anytime you see moles in a question, it's the ideal gas law. Okay, the only equations that we're doing in class this year that have moles in it is ideal gas law. So that's a huge hint that you should be using that one. Okay. Because I know you've already done this, you're just checking your work. Liters is a volume. ATM is a pressure. What volume, they're asking me, at this pressure. So the variables here, I have 2 volumes and 2 pressures. And PV, let's see if I can make this work. V, I don't know if that's really going to work. We'll see. Is Boyle, kind of. Yeah, that worked. So this is a Boyle's law problem. You don't have to calculate it. You're welcome. What is the final volume? Okay, so there's a volume of a gas that fills. Liters volume, Celsius is a temperature, and we're moving it to standard temperature, which is 273 Kelvin. So I have 2 volumes and 2 temperatures. Volume and temperature has a direct relationship because it's DirecTV. And who watches DirecTV? Why, Charles, of course. Okay, hopefully that makes this homework assignment much faster for you, that you're just choosing whose gas law it is, but not having to do the calculations. Okay, good luck with your lesson 2 homework assignment. Please take a look at the video tutorial if you need that, and then remember that your end of the week quiz is part of a major grade, so do your best work. Thanks, y'all. We miss you.